So now let's take a moment to dive a little bit deeper into what a database is and kind of concepts to be thinking about when you're going to be using databases. Now, the first thing to understand with databases is that databases store records. So again, when we talk about data, this can be confusing, especially for new people, because data just kind of seems like data. Like, what's the difference between a file and a record? Essentially, when we're talking about records, all we're talking about is text information. So again, imagine we have sensor values coming in from the outside world, and we want to be able to store those sensor values so that we can determine like ranges of the values or look at how those values change over time, right? So basically, those values will come in. You'll need a timestamp, so basically just a text timestamp for when the value came in. You may need a location identifier, so where is that sensor located, the sensor values itself, so a sensor may only send one value in, or depending on the sensor suite, you may send up to like 10 different values in. All of that data will need to be stored in the record, and that is what a record looks like. And again, that's what we're going to be talking about in the database world. If you create a blog post or if you have a work order system, again, taking the timestamp, having the title of the post or the work order that's coming in, having a description or the post, thing that's going on, different tags, that type of thing, that is all going to be text-based, and so that's what we're going to store into a database. When we talk about other types of data, though, again, when we're talking about files, so when we talk about files, MP3 files, PDF files, video files, any kind of like .doc files, .txt. So even though it's TXT, it's a text file, right? That is what is going to go into what is called your data store. Basically, it's going to go into file storage. So you basically are going to have what's called a volume or a block or whatever somewhere, basically a bucket somewhere, and basically all those files will be stored into that volume, into that place of storage, and that is something entirely different. That's when you start talking about things called RAID arrays, all kinds of different things. So when we're talking about databases, though, all we're talking about is a way to store and be able to access records in a very efficient fashion. So when we're storing that data into records, we need to think about the data types that are going to be going into those records within the database, right? So the data types we've talked about before in the Python series and any other kind of coding class, basically you can have ints, so ints are whole numbers, floats, so floats are decimal point numbers, boolean is 1 or 0, basically true or false, that type of thing. Basically within that database record, you will be able to identify the data type that was supposed to go into each column, basically for that record, so that you make sure, hopefully, you don't screw things up too much. We'll talk about that. That's another little quirk with SQLite we'll talk about in a different session. But basically, the idea is if you're trying to figure out the average age of all the students in a particular class, you don't want the age to be 12, 13, 14, 11, Bob. Like, how do you add that up? How do you add 11 plus 12 plus 13 plus Bob up? Or average that out? That's one of the things we're talking about, things like data types. Actually, again, data types in SQLite gets to be a bit of a squishy issue. We'll talk about that in a different class. One of the things to consider, though, is you may have heard of the data type called blob. So I, as Eli the computer guy, I do a show called The Daily Blob. And one of the reasons it's called the blob is because the blob data type is actually basically any kind of data you want to throw in there, including files. You can actually put an MP3 file directly into your database or a PDF file directly into the database. You can do that. You can do that. Do not do that. Almost ever. Basically, if you do that, your database just becomes insanely large and you run into a whole bunch of other quirky issues. So when you're dealing with files and you're dealing with database records, basically what happens is you create a pointer in the database record to point to where the file is stored. So let's say you have a featured image for your blog post, right? So when you look at the record, you have a timestamp, you'll have the title of the blog post, you have the content of the blog post, you'll have the tags, and then at the end of it, what you'll have is you'll have a file path that points to where that featured image is stored. So when somebody clicks on your bottled web app to open up the blog post, basically all the text will come from the database, and then the pointer in the database that points to the image, basically that will point to the image, and so the image will come from the file storage location, not necessarily the database itself. So those are some of the things to be thinking about when we start talking about things like data types and databases and how that pertains to records. Now, when we start talking about database engines, like many things back in the day, there used to be not very many of these. Basically, you had like 3 or 4 to pick from, and you picked what database engine or system that you were going to be using based off of your particular requirements. So when we talk about the database engine or the database system, we're talking about the overall product itself. So SQLite is the overall database system that we are going to be using in this series. Now again, when you're using SQL, you can use this with other database systems, right? So there's MS SQL, that's Microsoft's version of a relational database. Oracle obviously has them. MySQL or MariaDB, those are also database systems. And there's Postgres, right? So if you were looking at this like 5 or 10 years ago and you were thinking, oh, which one should I use? It's pretty simple, right? If you have a crap ton of money and your company is going to get audited a lot, you use Oracle. Right? That's just how it works, right? If you're already on the Microsoft stack, so you probably already bought MS SQL licenses for some reason already, you just already have 100 of them for whatever reason, then you would use MS SQL, right? Depending upon the institutional knowledge in your company and exactly what you were trying to do, you might use MySQL or you might use Postgres. MySQL and Postgres are basically open source. MySQL got forked to something called MariaDB. Anyways, basically, depending on your circumstance, you might use one or the other. It was pretty simple, right? You grab a cup of coffee or you grab a beer, you write down your requirements, you paint by numbers, and you pick one. So one of the things you might be thinking about now is as you're watching this particular video, you're like, okay, well, SQLite is fine, Eli, but what database should we really use? Well, the issue that you run into, again, the modern world of technology, is there are so many options nowadays. There's so many options nowadays. I literally saw a Fireship video. So if you go to YouTube, there is a channel called Fireship. Highly recommend you follow and watch those videos. They're great little 3 to 4 minute videos that explain different concepts in technology and programming. And the thing was, I literally about a year ago, I sat down to watch one of his videos, and it was a video on the 30 most popular database systems. Oh, at which point my brain just started leaking out my ears. And that's one of the things you do have to be thinking about, like now. So I'm actually creating this video, this class in 2025. So there's only going to be more options going forward. So that's going to be something that you are going to need to be thinking about as you plan for your projects in the future, is trying to figure out which one out of literally just a zillion different options that you should select for whatever project that you're going to be building for. Postgres nowadays is incredibly popular. Postgres does a lot of cool things and it's used for a lot of different projects. I would actually say, when in doubt, probably go Postgres at this point in time. But the thing to be considering, again, if you're going to be developing a project that you expect to last for 5 or 10 years, basically people beyond you are going to be managing and maintaining, when you initially decide which database system that you're going to use, that is going to be just a tremendous amount of research and decision that you're going to have to make. So that's one thing that I'll just warn you here is, yeah, sometimes having more options is actually a really big problem. So when people talk about database systems, one of the things you'll hear is SQL, Structured Query Language, or NoSQL databases. And so you might get confused about what this means. Basically what we're talking about with SQL database systems, basically relational database systems, is they have something called a schema. And so what the schema is basically when you sit down and you create the architecture, the system for what your database is supposed to look like. So there are tables, so there are individual tables to store data. Then within those tables there are columns. And so the columns are the different types of data that are going to be stored. Again, things like a timestamp, a name, post information, tags, that type of thing. There's going to be the data type that's supposed to go into those columns, right? And then there's something called joins. So when you deal with relational databases, each table is supposed to contain a specific type of information, and then basically you can connect tables together using something called a join statement that we'll talk about later. So the good thing about relational databases is that they should be very reliable, and they should be very stable, right? So if you have an inventory control system, it's very important that your database doesn't flake out and lose records. So again, or something like, let's say you have an invoicing system. You don't want your database system to just lose an invoice, right? And so that's what a relational database system is going to do for you, is it's going to allow you to basically set in stone, more or less, what all the data is supposed to look like, and then as people interact with that database, you know that your data is going to be stable and is going to be secure. Again, it's good for things like inventory control systems, work order systems where you don't want to lose information, any place where you don't want to lose information. The issue with that, though, is if you have to alter the schema, so if you have to change things in your database, that can be brutal. That can be absolutely brutal. Don't do it. Don't do it. That is why we have whiteboards in the tech world. Design first so that you do not have to change later. Because if you go into that schema and if you make a change that wasn't the right change to make, all hell can break loose, which is a really bad problem. So that's where we come to what are called NoSQL database systems. And with NoSQL database systems, the great thing is there's no schema. So basically, when you input data into the database in the form of records, whenever you're inputting the data, you essentially assign basically what the column would be with the string that's going into that database, and then that's just stored as it is, right? So basically you say, I want a timestamp, and I want the post title, and I want this, and that goes in. And the next one, you may want some other information, and that goes in. There's no schema. You don't have to worry about the joins. You don't have to worry about any of that kind of stuff. And the great part about that is, with NoSQL database systems, is generally they're just incredibly scalable, and it's really easy for coders to deal with because they don't have that administrative overhead. They don't have to worry about the schema. They don't have to sit at a whiteboard for 2 weeks before anybody sits at a keyboard to actually type something out. They can just immediately start throwing stuff into your database. Well, if you're not a noob, you probably understand what a disaster that can be, right? When your coders can throw anything they want into your database, you can just get a really big database that is completely full of garbage. So that's one of the problems that you can deal with. The other thing with NoSQL databases is that they're good. They're incredibly fast and incredibly scalable, and they were one of the innovations for basically social media back in the day. So think about it with social media, right? You need a database system, you need a place in order to store records, you need it to be incredibly fast, you need it to be incredibly scalable, and you know, if you lose a tweet every once in a while, is anybody really gonna care? Again, that's one of the trade-offs. That's one of the trade-offs you have to be thinking about with technology. Relational databases, incredibly reliable, but a little bit slow. And again, with scaling and all that can be difficult. NoSQL database is incredibly easy to scale, incredibly fast. Once in a while they lose some data. right? That's just kind of how they're built. And so that is what you need to be thinking about whenever you hear about SQL, structured query language, or NoSQL databases. That is a brief overview of the differences between those overall systems. So when we talk about SQL or relational databases and we talk about NoSQL databases, you'll hear the concept of ACID types of databases and base types of databases. And maybe by bullet pointing this out, it might make a little bit more sense from a technical standpoint. So when we're talking about SQL, structured query language, or relational databases, you have what is called ACID. Atomicity, is that how you say it? Consistency, isolation, and durability, that's what you get with a relational database. Atomicity, anyways. Oh, it sometimes sucks to be a teacher. Anyway, that word, atomicity, right? A transaction is treated as a whole unit. If any part fails, the whole transaction fails. So think about this. Think about this when you're dealing with a database system. Like if you want to pull, let's say you have a customer and they have money in an account. Right? So they prepay into your system in order to purchase products. So they prepay, so you have money in their account, and when they buy products, that has to come out of inventory. So money comes out of their account when a transaction happens, and something comes out of inventory. What happens if you don't have atomicity, right? The transaction isn't treated as a whole, and so just the money from the account is reduced, but the inventory isn't reduced. Right, or the inventory information isn't shipped off. So you take money out of the account, but you don't actually ship the user whatever it is that they're supposed to get. Right, that can be a problem. So the idea here is when you have a transaction, either the entire transaction completes, all of it completes, or none of it completes. You don't want what are called soft failures. I've talked about soft failures in many other classes. Soft failures is when things kind of sort of work, but not really. So it looks like they work, but they didn't fully work. And so you sit there scratching your head for like 5 days trying to figure out what's going on. You just keep looking at it, you're like, that doesn't seem right. But it also seems to work, so what are you gonna do? And then you find out later, oh, something was wrong, right? That's basically the idea here, right? You're going to, if any part, you're not going to get a soft failure. It's going to be a hard failure, right? Consistency. Basically, the transaction must maintain the consistency of the database. So the database is a whole. When the transaction was recorded, the database maintains being a whole. The database is consistent. When anybody goes to the database, they will get the values in the database that are up to date up to the last whenever there was a modification of the database, the modification of any records. Isolation. Transactions are executed individually. So sometimes with different database systems, they can actually batch what are called transactions, basically statements, where they might put 1, 2, 5, 10, 20 together and all ship them to the database server in order to try to process. Basically, again, you can run into some weird issues there. So the idea with ACID is this isolation. Transactions are done individually. Again, if that transaction fails, it completely fails, but it goes through this processes, this processes, this processes, this processes, this processes, right? And then you get to durability. Once the transaction completes, the changes are permanent. And again, that goes back to the whole consistency of the database. When you modify the database is the database. You don't have to worry. You don't have to worry that maybe 5 minutes from now, the database, even though you haven't done anything to it, the database will look slightly different. And then you're probably sitting there going, well, that seems weird. Eli, why would you bring that? Eli, why would you say that you don't want to come back to your database 5 minutes from now, and even though no additional transactions have transpired, that it might be different? Isn't that how databases should be? Well, that's where you get to the base databases, NoSQL, right? So basically, schemaless, incredibly easy to scale, incredibly large, a lot of great things, but again, there's a trade-off there. So when we talk about base, basically available. The database will always provide a response, but may not be the most up-to-date, right? So if you're thinking about What is your current inventory? You want it to be the most up to date. That's an incredibly important thing. If you're thinking about the account balance for one of your customers' accounts, you want that to be the most up to date. That's going to be a really important thing. But again, think about this. If you're just pulling in tweets, so let's say you go to Twitter and you're just pulling in all the tweets from the people that you follow, you want a response, right? You want the database to respond with information, but it doesn't have to be the most up to date. If somebody put out a tweet like 2 seconds ago and you refresh your page now, is it incredibly vital that you get that updated tweet, right? As soon as you refresh? Probably not, right? Again, for scalability concerns and that type of thing, you'll get the tweet when you get the tweet. And that's basically what we're talking about when we talk about basically available. You will get a response from the database, but it might not be completely up to date. Soft state. Again, this goes back to that whole transaction thing. The system may be in a state of change even when no transactions are being made. And so that's one of the things with NoSQL. In order to be able to scale and become so large in its systems, right, it's pushing data around, storing data, doing all this kind of stuff with the records and that type of deal. So even when no transactions are going in, there's no inserts, there's no updates or anything like that, it's still shuffling stuff around, so it may be changing itself even when you're doing nothing to it. Again, an important thing. When you're dealing with tweets, again, doesn't really matter. When you're dealing with actual inventory control systems, absolutely does. And then eventual consistency, right? So consistency here with ACID, transaction must maintain the consistency of the database, right? The database is the database. You make a change in the database, and that is the database, right? Well, with base, eventual consistency means, well, again, it's shuffling data around, it's moving stuff here, it's moving stuff there, it's trying to figure out what to do with all these different records, and so it will be consistent. It's kind of like a teenager. When you ask them when are they going to turn in their homework, they will turn in their homework. They're not really sure when, and they might not actually get around to it. But hopefully they will, hopefully, right? And that's basically the idea here with that kind of database system. And again, that's one of the reasons why it can be so scalable, is since everything doesn't have to be absolutely consistent, it can take more time to be able to store the data and be able to figure out what to do with it. So that's what we're talking about. We're talking about ACID and we're talking about base. So with SQLite, we're going to be dealing with ACID type database systems. This is going to be a relational database system. And again, SQLite does not have the security, again, privileges and all that kind of stuff that other database systems such as Postgres or MySQL do. But as far as the SQL component is, as far as the relational database component is, it does have all of this ACID capability. Now, a final thing to be thinking about when we start talking about databases in the modern world of databases, not how they used to be, not how it was way back in 2000, which, holy crap, is actually a little while ago. We're talking about in the modern world. One of the things to be thinking about with different database systems, again, back in 2000, is we actually had to build our own database systems, and things like hardware resources were a real constraint that we had to figure out what to do with, right? And that was one of the big things when you're dealing with things like relational databases, is many times you had to put the servers themselves in what's called a database cluster. And then those all the servers in that cluster would replicate data to each other, basically replicate records to each other to try to maintain the consistency in the overall cluster, right? So if you needed to keep a lot of data, you might have 5 or 10 MySQL database servers in a cluster. They were doing replication and they were doing a whole bunch of things like that. That was one of the big issues with relational databases. Again, maybe only about 10 years ago, is what we talked about, again, with that administrative overhead. Not only did you have to worry about things like security privileges and that type of thing, you also just had to, figure out what to do. Like what if a database server just completely fails? What if a database server, a hard drive, is kind of flaky on it, so it's not performing the way it should? How do you design a database architecture to be able to maintain the availability of the data? That was one of the good things with NoSQL database systems back in the day, is that they were just simply a lot easier to manage and maintain. Basically, you spin up a server, you connect the servers to each other, and again, especially with that whole eventual consistency thing, they'll kind of figure it out. Again, which is not the same thing as relational databases. What becomes curious, though, is we get to the IaaS world, the infrastructure as a service world. And when we talk about this, we're talking about things like AWS, Amazon Web Services, their database offerings, or things like Azure and their database offerings. And they have what are called drop-in replacements for database systems such as MySQL or MariaDB or Postgres. Basically, the idea there is that you can have your Python code or whatever be able to communicate with their infrastructure as a service, and then you just simply pay for however much database system that you use. So I think with AWS it was called Aurora, at least it used to be called Aurora, and you could get up to it was back in the day, it was like a 64 terabytes of data within their systems and literally not have to worry about it. You don't have to worry about replication strategies. You don't have to worry about clusters. You don't have to worry about hard drives being flaky or any of that. You could just point, all your SQL statements at their particular server, and they just maintained all of it. So that's one of the things to be thinking about too when you start talking about these database systems. And again, we start talking about modern architecture. How you would design things 15 years ago with something like SQL or a relational database system is not necessarily how you would design them today. Again, with IaaS, infrastructure as a service offerings, that basically they take a lot of that administrative overhead away from you so that you don't have to worry about it anymore. So that's the basic idea of what a database is. If you're still a little confused, don't worry. We've got a whole bunch more classes in this series, and hopefully by the end of it, all of this will become much clearer to you.